Hey, Jonathan here at Colfax Math. Today I'm going to go over the unit circle, angles of rotation in degrees in radians, and then these ratios to sides of cosine and sine, and what all those exact values are. So stay tuned and we'll go through that.
Measure the height. Yeah, no, measure the width from here to here.
Laminated overnight on a CNC cut jig. Okay, so starting out with angles of rotation, the first thing is degrees. So if you start here, everything's defined as you start on the x-axis right here, rotate counterclockwise, and end right here back on the x-axis. So if I'm in degrees, I start at 0 degrees, I go all the way around to 360 degrees. So half of that would be 180 degrees, half of that 90 degrees, and then, so that's 90, 180, 270 would be my 3/4 mark. Now I'm going to cut those in half again, so half of 90 would be my 45 degrees. 45 and 90 would give my 135. 180 and 45 would give my 225. And then 270 and 45 right here would give my 315. And then 45 would put me back at 360. There are two triangles I have to know. The first triangle I need to know is a 30, 60, 90. You see it down here. In that 30, 60, 90, the side opposite 30 degrees is 1, the hypotenuse is 2, and the side opposite 60 degrees is √3. So the important thing here to note is opposite 30 is 1, opposite 60 is √3, and the hypotenuse is 2. The second triangle you have to know is an isosceles right triangle. Isosceles meaning two sides are congruent, so angles opposite them are congruent as well, and right for the right angle. The ratios to sides here are 1, 1, and √2. So how that's going to come into play here in my unit circle is because I'm going to use a 30, 60, and 45 to identify my other angles. These are the only two triangles you really know for exact value. Well, and an imaginary set, I'll talk about those. And those are actually going to be the other angles in here. So the first angle will be your 30, the second angle your 45, and the third angle 60. So those are your reference angles. So in a 30, 60, 90, you have the ratios of sides, right? So you'll be able to find these coordinates here too. Because if you draw in a 30-degree angle here, this would be a 30-degree angle. The side opposite 30 would be 1, hypotenuse would be 2, and the side opposite 60 would be √3. I know there's a lot of information here. So we're going to go back and revisit that in a minute or two. I'm going to finish doing all my angles all the way around. So these are still going to be my 60 reference angles. And the reason why the way this stuff works together so beautifully is that we started with a 360-degree circle in the first place. And 360 is a perfect number because it's divisible by 30, 45, and 60. So you could split it into quarters, you could split it into eighths, you could split it into sixths, you could split it into twelfths. And all those numbers work out to give you exactly a 12th. Okay, so we got 30, 45, 60. Here's my second 60-degree reference angle. So this is 120 degrees off of the x. 135, and this is 30 degrees down here, 150. So these are my 60, 45, 30 reference. Here's my next one at 210. 225, and this is 60 reference back here to 240. And then over here, this 60 back here, so it's my 300, 45, and then 330 degrees. So that's how all of my angles and measure to give me both my exact value triangles of 30, 60, 90, and isosceles right. And now these coordinates are going to fill in the ratios of sides. So the first coordinate right here on my unit circle, again, is called a unit circle because the radius is equal to 1 unit, would be the coordinate over 1, up 0. This coordinate here would be over 0 up 1. This coordinate here would be over -1 up 0 over 0 up 1. And then finally, not finally, we're going to do radians after this, but these ratios of sides here, the side opposite 30 would be 1 over 2. Side opposite 60 would be √3 over 2. So how do I get to this coordinate? I go over √3 over 2. That's the length of this side, or cosine. So this is √3 over 2, kind of smaller. And then the up would be 1/2. And then this is isosceles right. So the adjacent here would be 1 over √2. And then the opposite would be 1 over √2. And then over here, this is going to be reversed. Now my adjacent leg, this leg right here, will be opposite the 30. So it'll be 1 over 2, and then this will be √3 over 2. One thing I'll also note right here, these 1 over √2s, 1 over √2, a lot of times you rationalize the denominator, meaning get rid of the square root in the bottom. So I multiply by √2 over √2 to get √2 over √4. So √2 over 2 is the same as 1 over √2. So you might see these as √2 over 2. Then all of 45s are going to be the same. So these are also going to be 1 over √2, 1 over √2, 45 down here, 1 over √2, 1 over √2, down here, 1 over √2, 1 over √2. However, in the other quadrants, you got to remember the positive negatives. So everything in the first quadrant is positive, positive. Everything in the second quadrant, because I go over from right to left, will be negative, and then I go up. So in the second quadrant right here, so this is my second quadrant, I go over to the left. So my first value will be negative, my second value will be positive, because I go right to left and then up. Down here I go negative, negative, so this is negative, negative in the third quadrant. So this value would be over negative and down. Here I go over positive and down, negative in the fourth quadrant. So these are going to be positive first and then negative second. So those are my 45 references. Now I'll do my 30-degree reference. So here's my first 30. Here's my second 30. So my adjacent leg right there will be √3 over 2, but it'll be negative, and then this will be positive. So it's the same as that. It's just negative, positive. Over here, my next 30-degree reference here, 30 because I'm going back up. My reference angle here is 30, right? So my adjacent right here, would be the side opposite 60. So it'll be √3 over 2. It'll be negative, and then I go down negative as well. And then lastly, my last 30-degree reference here is going to be I go over a positive, √3 over 2, and then down to negative. Now I'm going to do my 60-degree reference, right? So 60-degree reference. My adjacent is 1/2. My opposite is √3 over 2. My adjacent is 1/2. My opposite is √3 over 2, and it'll be negative, positive. Down here in my third 60-degree reference, my adjacent is 1/2, and my opposite √3 over 2, and both of these are negative in the third quadrant. And lastly, this one right here, 60-degree reference, right? So the side opposite 60 is √3. Wait. This is my 60-degree reference here. The side opposite 60 is √3 over 2. So that's my opposite, so that's how far I go down, and then therefore my adjacent opposite the 30 is negative 1/2. Nope, that's positive 1/2. And I got a lot of writing in here. You got to do this quite a bit to get it down. Okay, so I know it's a lot of information. I can go over one last thing. All of these things hold true in radian measure as well. The biggest idea in radian measure is that you know that circumference is equal to pi times diameter. And if your circumference were measured in inches, your diameter would be in inches. You divide both sides by diameter in inches. And I can see when pi is by itself, my units cancel, and pi is unitless. So radian measures are unitless, and that's the whole point of them. So if my unit circle has a radius of 1, its circumference would be 2 pi. That 2 pi could be an angle of rotation all the way around, or the length of the circumference all the way around. So now, going all the way around could either be 0 or 2 pi. If I cut that in half, my half circle would be pi. Again, these are radians, and this is degrees. Half of pi is pi over 2. So now I have 1/2, 1, 1.5, 2. And I'm going to cut those in half. So I'm really got to be good with my fractions here. Half of pi over 2 would be a quarter. So now I have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, back to 8/4. Now this is my 30 reference, and this is my 60 reference. So now I'm going to look at my 60, which is 1/3 of 180. So I'm splitting pi into 1/3. So this is 1/3, 2/3, 3/3. Then at this 60 reference here, this is 4/3, 4/3. This right here is going to be 5/3. Back to 6/3. 6/3 is 2 pi. Now at my 30 reference here, I'm going to be 1/6 of the way to pi. So this is 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, and 11/6. So that's in radian measure, and really you got to draw this thing out and think about it and work on it quite a bit. But if somebody says to you, what is the sine of 150 degrees? Well, I guess not somebody on the street, but if a math teacher asks you sine of 150 degrees, what they're saying is create a reference angle at 30 degrees and then tell me the side opposite that. So it would be 1/2. Remember, the first value is cosine, second value is sine. So cosine of pi over 3, cosine of pi over 3 would be the first value at 60 degrees, which would be 1/2. Cosine of 11 pi over 6, root 3 over 2. Sine of 11 pi over 6, negative 1/2. And lastly, the hardest ones, I guess, are the imaginary triangles. But you have these coordinates here, so the cosine of 0 degrees is 1, the sine of 0, 0. Cosine of 90, 0. Sine of 180 would be 0. Cosine of 180 would be 1. And lastly, remember that tangent is equal to the opposite over the adjacent. And we know that the opposite is sine. Right, here's my right triangle. Here's my angle of reference. This is opposite. This is adjacent. And we call our adjacent cosine and our opposite sine. So tangent is opposite over adjacent. There's going to be sine over cosine. So tangent of 180 would be 0 over 1, or 0. Tangent of 270 would be 1 over 0, which is undefined, and that's also why you have an asymptote when you graph it at 270. Let's take a look at cosine of 0 would be 1, sine of 0 would be 0, tangent would be 0 over 1 or 0. So I know it's a long video, there's a ton of information here, but hopefully that'll help you with the unit circle, both in degrees and radian measure, and then all the exact value triangles that you need to know are really all based on your 30, 60, 90, your isosceles right, and then these imaginary triangles as well. So thanks for watching. I'd like to hear your comments below. Hit subscribe if you like the video.